Hello and welcome back. It's time once again to try to fix something, and today I have a PS4 Fat 1215A that I have already taken the bottom off. And let me show you how it looks under there. Nice and fuzzy. Pretty nasty. But it's acting kind of strange. I thought I might make an interesting video. Now let's see, I can't turn it on this way because that little button is broken, so I can't do that. So we will just try to actuate the Blu-ray mechanism in here, and you can watch it. We come on, we get about, one flash of blue, and we cut off. And that's what she does. And basically won't do anything else. I think the eject will beep. Yeah, so standby power is still there. But, let me unplug it so we can get another shot at this. It's hard to do. Okay. So if I stand it up on its side here, where you can see the bottom, we have to put something under it so it doesn't fall over. Get it all standing precariously. Alrighty, so watch the fan. When I trigger it here, I'm going to trigger it again on the Blu-ray mechanism. The fan tries to spin for a moment, which kind of makes me think that the 12 volts is coming up and shutting down. So maybe we just have a power supply problem. So I guess let's see if we can swap out the supply first thing and see if it improves any. Yeah. All right, our test supply is in there. We're ready to see if she's improved any. I keep wanting to hit the power button and I can't do that. Okay. Fan bumped again. Nope, no improvement. We're shutting down immediately. Or within like a second and a half. So this is going to be a more serious problem than just a power supply, I'm afraid. Alright, I've got the metal shield off, and the board was covered in dirt and dust. I had to take a toothbrush to it and anyway clean it so I could see what I was doing in here. And I've got a crazy theory. I'm just wondering, the power button doesn't work. It's just like there's no click at all when you push it in there. What is the chances that that button is like crushed in some way and is stuck down, and it won't turn on, but it will turn off? Like if I wake it up with the Blu-ray actuator, is it then seeing the switch being held down and shutting off? It's a crazy theory, but I think I'm going to chase it before I go too deep down the rabbit hole. Let's just look for something simple. Here we are inside the workbench. We're taking a closer look at this board. And I can't help but notice the copious amounts of white thermal compound, because that cures everything. But let's take a look under the microscope at this micro switch. And you can see it's pretty well busted up there. Let's check with a meter though. If I can get it in continuity mode. Okay. And from top to bottom. Nope, she is not shorted. So that theory's out the window. So that's not our problem. Alright, our problem is not our switch, although I do need to replace it. Let's look around the board, see if we can find anything that doesn't look right. If I can get my ground connected here. I may have to get a better ground. Sometimes you can just place them in there like that and you get a good enough connection, and sometimes you don't. What do I read here? Yeah, close enough. So what do we have down here on these coils going into the processor? 11 ohms, okay. And these are all the same. And then this one down here, 36 ohms, okay. Up here, I believe these are for the RAM. I think this is like 1.5 volts, 36.6 ohms. And I think this one's like 9/10. Where's the best place to get on it? Right here on the coil, I suppose. Ooh, 0.14. Now I believe both of these are going to the RAM. I think this is 1.5, and I think this is, like I said, 9/10, 0.8 something usually, 0.85, 0.89. So we've got a short somewhere, possibly related to the memory. But there are a lot of capacitors on that rail also, all scattered around the board, you know, on the other side of the board where the RAM ICs are. There's capacitors everywhere. So maybe we we'll solder a wire to this coil and inject about 1 volt, and let's see what's getting hot. So we get that hooked up, and I'll switch to the thermal cam. We'll see what's getting, hopefully something's getting hot. Let me show you how I'm hooked up before I switch to the thermal camera. I've soldered a wire straight to this coil for this roughly 9/10 of a volt supply, and I'm getting a ground over here on this nice with a 12 volt connection. That's a nice strong connection for ground right there. And I am set for 1 volt at 1 amp, which we can increase that current. That supply will put out up to like 3.2 amps. So I think we're ready to try this. Hopefully my thermal camera is charged up. I've got it sitting here ready to go. Let me switch to it and we'll see what happens. All right, the thermal camera is on and going, and I'm still looking at the APU side of the board. I just want to see if there's anything shorted up here, you know, near those coils where I'm bringing my power in, but I have a feeling it's going to be on the other side of the board. Let's see what we get. Okay, 0.269 volts is all she can put out, and we have a 1 amp current flow. There's the APU. Nothing up in there. Let's go to the other side of the board. I don't see anything on this side. Oh, I am seeing something on it. What is that? What is that right there? Or is that just a reflection? Maybe just a reflection. Oh, here we go. Other side of the board. Yep. That would be one of our RAM ICs, I do believe. Yep. And I broke my ground loose. Lost my ground connection. Let me hook it a little differently here now. All right. So, right here. Yep. Maybe give it a little more current. See if it becomes a little more evident. 2 amps. There we go. We're at 0.541 volts, drawing 2 amps of current. And she is lit up nicely. All right, so there's our culprit. Still only 1 watt of power, so she's not very, very hot, but she's got to go. All right, I don't have any RAM on hand ready to go. I do have this board, though, that had a shorted processor that I am going to try to go ahead and pull the remainder of these RAMs off. And I'm trying to do it in a gentler way because I'm not sure if I've removed these things with just, you know, hit it with hot air from above and take it off and go. And I'm not sure if I've killed RAM in the past doing that. I don't know. So I'm going to try to actually put it on the preheater and get the board up to temperature and remove them with some little bit lower heat. Trying to be a little gentler with them. I don't know if I'm killing them with heat. I don't know. Don't know a lot of things. So that's what I'm going to do. Is I think I'm going to preheat this board and go ahead and remove all these RAMs, and I'll reball one for this board that we're working on now. Okay, our RAM IC has been changed, and I want to show you what kind of resistance readings we're getting. Right here we had a pretty dead short earlier. If I put my probe right there, red probe's on there, and the ground is the black probe. 49 ohms. And the other one here, this is the 1.5, 22.5. Okay. So yeah, that's an improvement if nothing else. I don't think we're shorted anymore. But does it work? Let me clean up this white thermal paste off here and see if we can do a quick test here inside on the bench. All right, I think we're ready to test this out. I've got my tiny heat sink on here and my test power supply in here on the workbench. Let's see what happens. Maybe, oh, I haven't changed that power button yet, have I? Okay. Can we do this right here? There we go. Blue light. And we're on anyway. And we're staying on. And we're overheating. Try that. Let me get my fan on. But I think we're at a blue light of death is what we are right now. I think we have a blue light of death. Okay, I've got a fan blowing on it. Let's try it again. Let me kind of push down on this heat sink a little. Get some better contact. And I do have a monitor hooked up back there, but it's not getting anything yet. So yeah, I think we're blue light of death right now. So either my RAM IC is no good, or I don't have it down properly, or I killed it with heat. That's kind of the options we're at right now. I thought I would give it a chance though to fall back to safe mode. Nope, she's going to overheat. She should have gone into safe mode by now. So, oh, we still got a problem, obviously, with that RAM IC. All right, well, I reflowed that RAM IC down at 350 Celsius. It was 340 I was using earlier, trying to be gentle with it. Sometimes I'm too gentle, sometimes not enough gentle. But I did reflow at 350 and it did nudge and move just like you'd love to see. So let's see what happens now. I've got power, I've got my heat sink. Are we improved in any way? Okay, oh, and we shut off instantly. I must have, let me try let's check this 12 volt supply. Maybe I don't have it quite lined up. Let's see. Try that again. Let's see. Okay, yeah, I don't think I had the 12 volts quite lined up. Oh no, she shut off again. Well, that's not good. I think I've made things much worse. Let me see what's going on. All right, I'm not for sure, but I think I still didn't have the supply lined up right. That's what it was. It was shutting down like it wasn't getting 12 volts. And that's about how fast they'll shut down when they're not getting the 12 volt supply. Let's try this again. Power on. I still have not changed out my little micro switch. Let's see what happens. Okay, we're on, we're blue, we're flashing. Oh, PlayStation logo. We got a PlayStation logo. We may overheat here in a moment because of my tiny little heat sink here. I'd just like to see it give a white light, but I think she's going to work looking at that. So I did not have that memory IC down all the way. Note to self. I was using 350C with maximum airflow and lots of flux, and I did not stop until it would wiggle when I nudged it. I think, oh, white light, look at that. Beautiful white light. Beautiful. I think she's going to overheat because she is burning my fingers. Maybe I can push down on it here. I've got a little fan blowing on it right there, but it's probably not going to be adequate for long. There we go. Looking for its hard drive. So I think we are in good shape. All right, I think I'm going to end this one right here. Unless, tell you what, I won't end it. I will finish putting this thing back together. I've already cleaning up the plastic parts. I'll put it back together, and then we'll put it all back together back out in the garage and see what it looks like. How's that sound? All right, we have changed out the 1 RAM IC, replaced the power button micro switch, thorough cleaning on all the plastic and metal parts, cleaned the Blu-ray out, cleaned the fan. She's fully reassembled. Okay, let's see what happens. And she shuts back off. Well, that's not good. What the hell happened? Problems. Well, it appears This video will never end. It seems like the power supply has quit working. Oh, you know what? Now the eject button's not working because I left the cable out. That's that problem. All right, I've swapped the test supply back in there. Will she stay on now? Let me pull this hard drive out. Does not sound very healthy. Well, I think it went back off then. On. Nope. Well, I thought I was finished with this one, but I don't think so. It is now shutting off. We did fix one problem. It had a shorted RAM module, but now it shuts off. And I think I found what the problem is. If I can demonstrate it to you. If I put this screwdriver right here on this corner and put just a little bit of downward pressure, the clamp is off the CPU right now. Turn it off and turn it back on. There we go. We get video and we stay on. It's doing the reboot because it doesn't have a hard drive in it. And there's our white light. And then we should get a message on the screen that we cannot find our hard drive. Right there. So yeah, I think we have a connection problem under the APU. And that's not going to be fun to fix. We're going to need an APU reball. So that's where we are. I can shut her off now. Okay. And I'll just show you here. Where I was putting pressure was right on this corner. And this is the one, the RAM module that was damaged. So I'm not sure if there's been some trauma to this corner. I don't know, but I'm pretty sure we do have connections broken up under this corner of the APU. We are inside of the workbench, preparing to do this APU reball. And I do not have what's considered the proper tools to do this, but I have been able to do it successfully one time. So I'm willing to try it again, because otherwise this thing is worthless. So what I'll be doing is I'll be using my preheater. You can see the model number over there if you're curious about it. To heat this board up, I'll start the temperature indicated here at 120 and let it sit there a while, then I'll ease it up. Eventually I'll get to like 200, maybe 210, 220 at most here indicated on this display. But I'll be watching really is the temperature on this meter, because I'm checking right here near the APU. And when it gets somewhere between 110 and 120, that's when I will bring in my hot air station at about 350 or 360 maximum airflow with this nozzle on there. I'll lower it down something like this. This nozzle is a pretty good match. And that with a lot of flux, and I have been able to remove these successfully. And that's what we're going to try today. Then we got to reball it, and then we got to put it back on. So let's get to it. Alright, we're about there. Wish me luck. I'm going to have my hot air station at 355 maximum airflow. And I'm going to come in kind of slowly from above here. We're just now approaching the point in which leaded solder would melt, and this is unleaded. I'm just checking it every so often to see if it will move. It is not moving. The heat is kind of getting to my hand. Still not moving. Still not moving. We're definitely not going to try to force it. I'm at approaching 3 minutes. They go on a lot easier than they come off. I'll go back on once you have leaded solder balls under there. Still nothing. Still nothing. This one seems to be unusually hard to remove. Looks she's starting to move a little. Yep. Yep, she's starting to move. Let me run my hot air up to 360. We need a little of something to get us over the hump. Yep. She's wiggling it on one side. I don't think I've ever had this much trouble removing one. There it goes. Oh, come on. Lay over on that pad, like so. Jeez, that took too long. Turn off the preheater. All right. Now we'll get our first look at the circuit board. Okay. Do we have any damage traces? Pads, I should say. Sorry, get my microphone. Don't see anything in that corner, but the other corner. No. Now this corner looked like it was a little bit cold if you look at those pads. They don't look like they ever had any solder on them. Oh yeah, this corner. All those are no connection though. All those are no connection. That shouldn't be an issue. I need to get to cleaning while this board is hot. Need to get to cleaning. Put some leaded solder on my iron here. Let's see what we can do. Okay. I have turned my attention to the processor itself. Alright, I think I've got my chips cleaned up pretty good, and I've got a really thin layer of flux on there. And I'm going to be using, let's see, some 0.55 millimeter balls. And my biggest struggle with this particular jig anyway is getting the clamp to hold the chip at the right height. Because if you get the height wrong, if you get the chips too low, the balls will get underneath the stencil. And if you get the chip too high, well, you end up getting flux on the bottom of the stencil and the balls stick to it. So that's kind of what I've learned so far. So let me get you maybe in a tripod and we'll pour some balls on this thing and see if we can get them floated in place eventually. And something else I've learned is don't grab it by the top, because the top is not attached and it will come off and all the balls will go where you don't want them to go. Come on. I still see a few empty spots in there. Oh, come on. Okay. Let's take a look under the microscope maybe. See how well we've done. Oh, I still see some empty ones. We have to help those along. Let's see if we can help those along a little. I guess I could grab one of these on here that's closer. All right, now what? Okay, I think we've got one in every hole. Now if we can get rid of our excess ones without losing the ones we want to keep. Yep, and some came out. Let's take a look. Pour some more back in there. Maybe they'll stick this time. Need one there. Alright, I think we're good. Let's just see if there's any going to stick to the stencil. I'm just going to rock it back and forth. And it looks like they're all wanting to stick to the chip, which is good. Alright, I'm going to try to pick this up very, very carefully. Oop, and I see a missing one right there. How did I miss that? Oh, it's stuck in the stencil. I see it. It decided to stick around in the stencil. It happens. I see one down here. It's moved. Alright, this is the part of the process I hate the most. Our balls have been placed, but we've got to flow them down to the pads. And some of them may try to merge together. It happens to me regularly. If you don't use enough flux, the balls won't stick down when you're trying to get them to stick. If you use too much flux, when you apply heat, the flux gets to flowing like a river, and the balls just all run together. So, you know, I'm still learning. So let me see if I can get these things flowed down. I'm going to be using my hot air station with no nozzle on it, 400 degrees Celsius, and the airflow way down. This airflow on this quick goes from, you know, 0 or up to 120. I'm going to be down in like the 20 range, probably 10, 20, something like that. Very little airflow. And let's see what happens. Well, we've had a few mishaps during that reflow. You can see we've got a couple of balls that have merged there. We're missing one there. It ran over and made what I call a super ball right there. So we got to fix that. And there's a merged one. Two of them have merged. And let's see over here. No, where was it? Over in this. There's one. merged together, and there's another one. So, and we're back to this corner where those two have merged. So, it happens to me. I mean, I've learned not to panic when this happens, and just keep reflowing them, and we'll go back, and it's not the end of the world. We'll fix those. But it's not ideal, but it happens. So let me kind of show you what I'm going to do if I can get my clamp to hold this chip. I'm going to take my thing like we'll just start right here. These two have merged together. I'm going to take my micro pencil and just kind of get up as much of that solder as I can. I may have to move to my other chip holder because this one is rocking around so much. Okay, we'll get most of the solder off on this side here. Then I'm going to take a piece of solder wick. And I'm going to cut it off at an angle such as like that. And I'm going to get down in here. We're going to try to extract that solder off that pad. Like so. Not bad. I'll go ahead and get this one too. And my little corner is getting filled up, so let me cut it off. That'll work. And well, let's see. I'm going to need some replacement solder balls there. Grab some of those out of my large pot of solder balls. Yep. Like, put them on this side. And I'm going to show you how I normally try to replace these. So I'm going to up my airflow. Maybe like 90 or something. I'm going to bring one of these in here. Got plenty of flux. Make sure I'm in the shot. I'm going to hold this with my tweezers. Get back over there. Just trying to run away. There we go. Oh, nope, don't do that. Right in there. I usually end up with my tweezers just behind the ball like this. There you go. You see it pop into place. Do the other one. Like, so my air is coming in from the right, so I'll try to support it from the left. Try not to burn my fingers. Come on. There you go. Now you saw it sat in place. Okay, so that's what I'm going to be doing for the next several minutes. Alright, here we are after a lot of cleaning, scrubbing with a soft brush, some alcohol, some canned air. She cleaned up pretty well. I think this will work. Zoom on in. If we can just get it back down. So that's our next step. Make sure the board's nice and clean. I'll put a little flux down on the board and then start heating it back up. And it should flow on quicker than it came off. Simply because it's leaded solder balls. Alright, our board is about up to temperature. I've got the APU lined up about as well as I can. And I'll be using my old phone over here as a stopwatch. This should take about a minute to 2 minutes. I'll be using 350 Celsius air from above, max airflow, and because this is leaded solder, it should flow into place reasonably quickly. I'm probably going to wait till at least like a minute before I try to nudge it, because if I nudge it too soon, it's a bad day. So, well, Let's see what happens. That's about 1 minute. I'd like to see this temperature get up more like 170. Which we are approaching rapidly. 1.5 minutes. Yep. She nudged and nudged right back. Yes. That looked good. Okay. Now that was just under 2 minutes. I'm going to turn off my preheater. I'm going to let it cool off. I'm not going to try to cool it down rapidly. I'm going to let it cool down slowly, which may take several minutes here, probably 20-30 minutes. I'm going to let it cool down on its own slowly, and we'll see if we've done any good. Well, power supply is hooked up. I've got my little tiny heat sink on here. I've even got a video cable hooked up back here in case we get some video. I've got a fan blowing across the heat sink here. Okay. I guess let's give it a try. AC power is on. What happens? Is it doing anything? I don't see the blue light. It's not. Blue LED failed. Oh, we have video though. We have video. Okay, where our APU is not dead. I'm guessing it's going to do a reboot. I'm holding some pressure on this heat sink, trying to keep that APU cool long enough for it to finish. Okay, still no blue light. I don't know why that is, but we do have a white light. Excellent. Do we have video again? Should be getting the message that it cannot find its hard drive. Alright, there it is. Okay, I think we're ready to put this back out there in the chassis and see if it's a little more stable now. Excellent. And yes, somehow I knocked off the blue LED. So let's change that out before we take it out there and put it in the chassis. Alright, we are back out in the garage. I put the board back in the chassis. I have not fully assembled it because that is a surefire way to jinx myself. So I'm not going to do that. I do have a test supply in there, although I don't think there's anything wrong with the other supply. The one that came in, I think it's probably fine. I do have the hard drive in it. The Blu-ray is connected. Let's see. I've never seen this thing actually fully boot. Let's see if it'll do that now. Well, should probably connect the power cord. They boot 50% faster when you connect power. And she should be initialized by now. All right, there we go. I did nice flashing blue light. I did replace the blue LED. Okay, we're doing a reboot because we've now found our hard drive. White light. Oh, and they show video faster when you actually connect the HDMI cable, or so I've been told. Okay, doing a system check. This is going to take a while. I'll bring you back. Oh, it didn't take all that long at all, actually. There's our logo. I think what I'm going to do, assuming she comes all the way up, before I call this one good, I think I'm actually going to install a game, and we'll let it run for a while. That's a beautiful sight. All right, let me get this game installed. Let's see, where's my controller? Nice, pretty red controller that I need to clean. Works, but it's got sticky buttons. Okay. Wonder if we have enough space to install a game. Blu-ray is working. Vibrating a little. All right, I'm gonna let this install and run, and I'll bring you back after it's run a while so we can say it's really good. Well, the console has been running about 30 minutes now. She hasn't blown up yet. Seems to be nice and stable. So I think we can bring this one to an end. I'm not sure how long this video is going to be or how I'm going to edit it, but I hope it was somewhat entertaining, educational, something. If it was, please give me a thumbs up, and I will see you in the very next repair. So long for now.